Okay, so we are going to learn how to factor two special types of products today, okay? So we're going to start like we've started for a lot of things. We're going to have two binomials here. I want you to notice the first terms match, the last term match, the signs are different. The first terms match, the last terms match, the signs are different. I want you to multiply these, and I want you to show that middle step. Some of you have been doing it mentally, and that's great, but show that step today because there's something I want you to see. Multiply these two, pause the video, turn it back on, and we'll talk about it. How'd you do? What do you notice? Here we multiplied two binomials, and usually when we multiply two binomials we get a trinomial. But in these cases we got two binomials again. What happened? Well, the two terms we combined were opposites, right? They were exactly the same, different signs, so they canceled. Minus 2m plus 2m canceled. Minus 2st plus 2st canceled. So since they canceled, since they went away, we end up with two terms in our answer, a binomial, instead of three. Now, another thing to notice, m squared is a perfect square, right? M times m is m squared. 4 is a perfect square. 2 times 2 is 4. This is a subtraction sign. So this is called a difference of squares. Okay, same thing over here. S squared is a perfect square. S times S is S squared. 4t squared is a perfect square. 2 times 2 is 4. T times t is t squared. It's subtraction, so this is a difference of squares. So these two special binomials, these are called a difference of squares. So what we're going to be factoring is differences of squares. So what you notice, it's a subtraction sign. That makes it a difference. The first term's a perfect square. Y squared is a perfect square. The last term is a perfect square. 16 is a perfect square. So we're going to set up our two sets of parentheses. Now, this is our last term, right? And it's negative. What does the last term being negative tell you? The signs have to be different, right? No problem. Now, what you need to think about these is, hey, the middle term went away. The middle term went away, so everything has to match. So the way I need to split up y squared is y and y. The way I need to split up 16 is 4 and 4. Everything has to match. So we could check this. Y times y is y squared. Minus 4y plus 4y. Those have to match. They have to cancel. And then 4 times negative 4 is negative 16. Notice the pattern here. If you notice the pattern, it will go a little quicker. Okay? 25m squared minus 36. It's a difference, and these are perfect squares. 25m squared is a perfect square. 36 is a perfect square. So we're going to set up our two sets of parentheses. The last term is negative, so that means my signs have to be different. And since there is no middle term, everything has to match. So how can I factor 25m squared and everything match? Well, 5m and 5m, right? 5m times 5m would be 25m squared. How can I factor 36 and everything match? 6 and 6. So everything matches. Let's check it. 25m squared, this would be minus 30m plus 30m, that would cancel. 6 times negative 6 would be negative 36. It all works, okay? You try this next one. Pause the video, try it, see if you can come up with the two binomials, then check your work. How'd you do? The last term's negative, so the signs have to be different. The only way to factor x squared is x and x, and I need everything to match because the middle term went away. So the things have to be opposites, they have to cancel. So the way I can factor 49y squared and everything match is 7y and 7y. You can check it. X squared minus 7xy plus 7xy would cancel. 7y times negative 7y gives me the negative 49y squared. Okay, let's look at these two. These are very similar, but this one, if you look at it first, it's a binomial, two terms, it's a difference, but 8 and 18 are not perfect squares. There's not a way to factor them where you get matching factors. But we don't need to forget, we can always look for a GCF. Is there something that divides 8 and 18? There is. We can divide everything by 2. We get what? 4 minus 9 n squared. So we do 2 times 4 minus 9 n squared. Don't lose that 2. Now, this is a difference of squares. So a difference of perfect squares will factor. The last term is negative, so my signs have to be different. I need everything to match because the middle term went away, so how can I factor 4 so that the factors are the same? 2 and 2. 9n squared, I can factor that into 3n and 3n. I need them to match so that the middle term cancels. You can always check it. 2 times 2 is 4. Minus 6n plus 6n would cancel, so that middle term would go away. 3n times negative 3n, negative 9n squared. Okay? Now, again, always look to see if there's a GCF. Is there something that divides 4 and negative 64? Yes, I can factor out a 4. What do I get? Times 16. Okay, I want you to pause the video and finish factoring because this is a difference of squares. And I got 4 times y plus 4 times y minus 4. Don't forget, when you factor a GCF, it needs to be in your final answer. Don't ever lose that GCF, okay? All right, now this next thing, this is not a big deal. You're going to be able to factor this even without knowing anything special. It's just another way to think about it. I want you to look at this. This is a type of problem we missed frequently on the polynomial operations test. I want you to pause the video, do what you think you're supposed to do here, but remember what it means to square something. Did you remember that to square a binomial, you have to write it times itself? This is actually multiplying two binomials. This is not, you cannot just give that exponent to both of those. You will miss it every time, okay? So you write it out twice because to square means to multiply something by itself. You multiply like we've been doing, and you end up with this. And this has a special name. This is called a perfect square trinomial because it came from multiplying a binomial by itself. We squared a binomial and we got a perfect square trinomial. So what's going to happen is you're going to get these polynomials and it's going to tell you to factor. And you're not going to think anything about it. You're going to say, okay, I'm going to factor this. N squared factors into n times n. I've got a positive last term. That's negative, so that means these both have to be negative. And let's see, factors of 36, that add up to 12. I get 6 and 6. You're going to factor just like you always have. But what you need to realize is, oh, this is n minus 6 quantity squared. So that means this was a perfect square trinomial, okay? So I want you to pause the video and I want you to work these next two. I'm going to talk about these two at the bottom, but I want you to work these two and check them. All right, so the first one, I got 3x minus 2 quantity squared. If you were to leave your answer like this, that would not be wrong. But if you're like on a multiple choice test or some other thing where you have to pick an answer, maybe a punchline or something, they're probably going to write it as a binomial squared. This one's everyone's favorite problem. It has S's and T's and pluses. Terrible things to do when we're writing and can't tell the difference, but I got 2s plus t quantity squared. Again, you could leave it like this, but you're probably going to see it like that if you're having to pick the answer. Now, down here, same idea, But remember to be looking for that GCF. Is there anything that divides all three of these? Well, I see that 3 goes into all of those, so I'm going to factor that 3 out. I get x squared plus 2xy plus y squared. Okay, now I'm going to factor again. I get x and x. I know they both have to be positive, and I think y and y. Does that do it? Xy plus xy would be 2xy, so this is my final answer. Okay? Now, this one I want you to do, but remember that when the first term's negative, factor out a negative. What goes into 3, 36, and 108? I think 3 does, but since the first term's negative, I want you to factor out a negative 3, do the GCF, and then you finish this problem. Okay, when I factored my negative 3, I got y squared minus 12y plus 36. Then I factored that. It was very similar to this one, right, with y instead of n. And then y minus 6 times y minus 6, I can write as y minus 6 squared. I can actually do that over here. I forgot to do that. I could write this as x plus y squared, okay? Not wrong if you don't, but you can. So that is how you factor perfect square trinomials. The biggest thing you need to get out of this video is the differences of squares. You can do a perfect square trinomial even if you don't know that's what it's called, but the other one is new. So if you have any questions, ask them, and we're ready to do some practice.